All right, so first we're going to review our Sohcahtoa from geometry several years ago. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we remember that?
Yes.
Make our geometry proud. Okay, so when we're talking about the unit circle, and I'm just going to draw in one of the triangles here. Here's our angle theta. This would be the opposite side, this would be the adjacent, and this would be the hypotenuse. Whenever it's the unit circle, the radius of the circle is always 1. So this hypotenuse is always going to be 1 unit. The adjacent side is the horizontal distance, so that's going to be represented by x. The opposite is the vertical distance, so that's represented by y. So if we take that and apply it to this, opposite over hypotenuse would be y over 1, which is just y. Adjacent over hypotenuse would be x over 1, which is just x. And then opposite over adjacent would be y over x. So that is how we're going to evaluate sine, cosine, tangent whenever we're using the unit circle. And then there are these other 3 trig functions. Does anyone remember how to even say these? Do you remember these from last year? What is this one?
That is
Cosecant.
Good. Well remembered. Cosecant.
Cotangent.
And cotangent.
Awesome. They are the reciprocals. So you're just going to flip whatever you have. Now I'm writing it out this way, but don't get hung up with the 1 over whatever. Don't put 1 over anything. Just take what you have there and like flip it over. Okay? And then what's important to recap from the unit circle, I'm going to write out the 3 angles, smallest to biggest. The smallest one is pi over 6. The medium one is pi over 4. The biggest one is pi over 3. The smallest side goes across from the smallest angle. The medium side goes across from the medium angle, and the biggest side goes across from the biggest angle. There's a lot of ways you can remember this, like 1, 2, 3. Some people remember like the pi over 3 goes with the root of 3, like the 3's are together. However you decide to remember that, but those are the angles that go across from the sides. So that's how they match up. So here's where you probably want to start writing some of these down and do some examples. For each of these, we're going to draw a picture and then answer the question. So we're going to draw a picture of the angle and then answer whether it's sine, cosine, tangent, or whatever. I get a lot of people at this point saying, but I can just look at the unit circle. Okay, but here's the thing. You're not going to draw an entire unit circle for every quiz and test you take. You're not going to draw the unit circle and have it sitting there by you when you take the AP exam. So you have to be able to do these one at a time. So pi over 2 on your unit circle is at the top, and that coordinate point is 0, 1. So that's our picture. That's like your work, quote unquote, for the problem. And then you answer the question. Tangent is y over x. So the y value over the x value would give us 1 over 0, which hopefully bothers you. What's the matter with this?
Undefined.
Undefined. And what that means is when we were graphing them, you would have an asymptote there at that point. All right, so again, draw a picture and then answer the question. So sine of pi over 3. Pi over 3 would be in the first quadrant. And across from the pi over 3, we have square root of 3 over 2. So that's going to go across from it. And that means that this other side has to be 1/2. So that is your work. And then you answer the question. Sine is the y value. So the y value from this picture is the square root of 3 over 2. All right, cosine of 3 pi over 4. So we're going to draw a picture. 3 pi over 4 is in the second quadrant. Your reference angle is pi over 4. Across from the pi over 4, you have the root 2 over 2. That means this side's also root 2 over 2. But we're not in the first quadrant, so something is going to be negative. Is the x coordinate negative or is the y coordinate negative?
X coordinate.
Good. So if you're not in quadrant 1, you just have to worry about those negative signs. So this is your work, and then you're going to answer the question. It says cosine. Cosine means we want the x coordinate, and that is the negative square root of 2 over 2. All right, this one is cosecant 7 pi over 6. So we have to figure out what quadrant 7 pi over 6 is in. Does anyone want to give that a try? Where is 7 pi over 6?
It's in the third quadrant.
Good, perfect. If you want to think of this, the flat line as being 6, 6, that's 1 whole pi. 7, 6 means that you just rotate it a little bit farther. So this will be our triangle. Reference angle is pi over 6. Across from the pi over 6, we have 1/2. That means the other side is square root of 3 over 2. And we're in the third quadrant, so they are both negative. So again, this is like your work. Then you answer the question. Cosecant means we're going to flip the y value. This one is the y value. So if we flip that, we reciprocate that, we are going to get what?
-2.
Perfect, -2. The sign is not going to change, positive or negative. You're just flipping the fraction. All right, moving on. Secant of pi. Pi is one of the quadrant angles that's not going to give you a triangle. Pi is going to be right over here. So what are the coordinates at pi?
-1, 0.
Perfect, -1, 0. Secant means that we are going to flip the x value. The x value is -1. If you flip -1, you're just going to get -1. 1 over 1 is 1. All right, cotangent of 11 pi over 6. So first we need to figure out what quadrant 11 pi over 6 is in. So what do we think?
It's in the fourth quadrant.
Perfect. 12/6 would be the whole way around. That would be 2 pi. So it's like we didn't quite make it. Reference angle is pi over 6. What goes across from pi over 6?
1/2.
Be the 1/2. That's the small side. That means the other side, square root of 3 over 2. One of them is negative. Which one is going to get the negative?
Y.
Y value. So -1/2.
Do not absorb information like this.
What's that?
Oh.
Did someone have a question?
It's not. Hold on a minute.
Why is it √3 over 2 and not √3 over 3?
It comes from the 30, 60, 90 triangles. Let me finish this, and if I have time, I will, at the end, I will go through that. It comes from your 30, 60, 90 triangles.
Okay.
Like if you did Pythagorean theorem for those, that's what it will come out to. I think I have an example here that has a √3 over 3. We have to kind of fix that. I think I have one on here somewhere. But it comes from the Pythagorean theorem. And I can go over that. I would just have to stop what I'm doing here to go over that. So let me finish this and we'll do that at the end. So this one is cotangent. Cotangent is x over y. So that is going to be square root of 3 over 2 over -1/2, which looks like a complete mess, but the 2's are going to cancel. You have √3 over -1, which would just be negative square root of 3. All right, so the next one, 4 pi over 3. We need to figure out what quadrant that is in. What quadrant is 4 pi over 3 going to be in?
Second quadrant. Third quadrant.
Third quadrant, good. This would be 3/3, so 4/3 means that we went a little bit farther. Reference angle is pi over 3. Across from pi over 3, we're going to have the √3 over 2. That means the other side's 1/2. We're in the third quadrant, so they're both negative. And then we're going to answer the question. Tangent is y over x. So that would be negative √3 over 2 over -1/2, which again looks like a disaster, but what's going to happen there?
Negatives cancel out and 2's cancel out.
Yeah, good. So we end up with √3 over 1, which is just root 3. All right, so now we're going to get into doing these backwards. Whenever it says arc and then the trig function or has a little -1, that means inverse trig. So it means instead of being given the angle and you're looking for the side, it means you have the side and you're looking for the angle. So your answer is going to be pi over something. The only thing with these is they're very much restricted to what quadrants they're in. These four, sine and cosecant, tangent and cotangent, those are odd functions, and they are either in quadrant 1 or 4 whenever you're going backwards. 1 if they're positive, 4 if they're negative. The other two, cosine and secant, those are even, and they are either in quadrant 1 or 2. So 1 if they're positive, 2 if they're negative. It's like the other quadrants don't even exist. And again, that's something I can go into. These are like whole lessons in pre-calc, but I can go over that during office hours, why that is, but it comes down to the domain of the function being restricted so that it'll pass the vertical line test. But you're very restricted with what quadrants you're in. So when we look at arc sine of 1/2, that's positive, so we're going to be in the first quadrant. Sine is the y value, so the 1/2 goes there. That means the other side is square root of 3 over 2. And the question is, what does this angle have to be? So what is the angle that goes across from the 1/2?
Is it pi over 6?
Yeah, good. It's the smallest one. So pi over 6 is your answer. So again, you're just doing that backwards. You have the side of the triangle and you're looking for what's the angle. So for this one, it's arc cosine and it's negative. So we're not in quadrant 1. Cosine is either in quadrant 1 or 2. So since it's negative, it's going to have to be in quadrant 2. Cosine is the x value, so that negative square root of 3 over 2 has to go down here. That means the other side is 1/2. And so again, what we're looking for is what is this angle? So the angle across from 1/2 is pi over 6. Now, when we were over here in the first quadrant, that just was the answer. That's all the farther that we rotated. But for this one, we need to get the actual rotation of the angle. So if we start here and rotate around to here, how far did we go? If that's pi over 6, how far was this?
$150?
Oh, you're using degrees, and we have to do.
Oh, yeah.
And I'm
That's
so
right.
sorry
Sorry.
about that, 'cause I know that's confusing, but we have to do radians.
Is it
All
2
right.
pi over 3?
Close. That's also in the second quadrant. If we think of this as 6/6, but we didn't quite make it, we go backwards a 6th. So if this is 6/6, 1 whole pi, if we go backwards a 6th, what is that going to give us?
5 pi over 3. 5 pi over 6, I mean.
Good. Yep, I got you. 5 pi over 6. So it's the amount of rotation. All right, arctangent of 1 can be confusing because when you see the 1, you think of the quadrant angles, like the 0, 1 and the -1, 0. But tangent means y over x. So we need to come up with a y value and an x value that if we did this over this, we would get 1. And the only way that can happen is if they are the same. So what do the sides of this triangle have to be?
2 over 2?
Yep, perfect. That's the only way we can get them to be the same, because anything over itself is 1. And so again, our goal is, what is this angle? And so the angle across from the root 2 over 2 is pi over 4. All right, cosine inverse of 0. This one is going to be a quadrant angle. Cosine is the x value, so we need a coordinate where the x value is 0, which is going to be right here, 0, 1. So if we rotate up to the top, that would be pi over 2. All right, and then this last one of these, it says square root of 3 over 3. I'm going to grab a scratch sheet of paper for this one. We need to come up with some way that tangent is going to end up being square root of 3 over 3. And there's only 2 ways that can happen. You can either have this square root of 3 over 2 over a half, or 1/2 over square root of 3 over 2. Those are the only options. So let's work through each of these and see which it comes out to be. For this one, the 2's are going to cancel. And so that's going to just give you square root of 3. For this one, the 2's are going to cancel and you get 1 over square root of 3. We have to rationalize that, which means multiply by square root of 3. And so that is going to give you square root of 3 over 3. So this has to be the option that we're looking at. This one was tangent. Tangent is y over x. So I know that the y value has to be a half and the x value has to be square root of 3 over 2. So when I draw that triangle, I'm going to be in the fourth quadrant because it's negative. My y value is the 1/2 and my x value is square root of 3 over 2. One of those is going to have to get the negative and it is going to be the y value. And then again, our goal is this angle. So what is the angle that goes across from the 1/2?
Pi over 6.
Good, that would be pi over 6. But we're not in the first quadrant, so my answer is not going to be pi over 6. We had to rotate backwards to get there.
Is it 11 pi over 6?
I know, I really wish it was. The reason it has to be negative pi over 6, you have to rotate backwards to get there, comes from the domain of the function. It's only available in quadrants 1 and 4. So it's like quadrants 2 and 3 don't even exist. They just are not even a part of the domain. So you can't get to 11 pi over 6 because you would have to rotate through them. And it's like they aren't even there. So you have to rotate backwards to get there. It's like this is some sort of void that's not real. So you can't rotate through them to get to 11 pi over 6. You have to go backwards. And again, it just comes from the domain of the function being really restricted. Do we want to do another 5-minute break before I do the graphs?
Yes.
We'll do that. Okay, let me stop the recording.